Sometimes people compute percentages from a two-way table that aren't really particularly helpful and are somewhat confusing. So how do we know which percentages are good to compute and which ones are not as helpful? So here's the question. Is there an association between gender and preferred type of snack? Which calculation, calculation A or calculation B, answers the question and why? So here we see 500 people, 400 males, 100 females, each asked which type of snack they prefer. And so we see how many males and females preferred each type of snack. So the first calculations that were done, we're looking at 300 divided by 390 and then 90 divided by 390. Okay, so this is in A, these are the categories that were done. And so how would we interpret that? So it says, so we see that 300 out of the 390 who preferred sweet snacks were male, and that is 77%. So it says 77% of those who prefer sweet snacks are male, and 23%, only 23% are female. It appears that males prefer sweet snacks more than females do. Okay, so that was the first. I'm going to erase this because I'm going to have to draw on this some more. The second one used these 300 divided by 400 and 90 divided by 100. So notice that's out of 400 males, 300 of them preferred sweet snacks. Out of 100 males, out of 100 females, 90 preferred sweet snacks. So since the proportion of women who prefer sweet snacks, 90%, is higher than the proportion of men who prefer sweet snacks, 75%, it appears that females prefer sweet snacks more than males do, although both genders prefer sweet to salty. So which of these is a correct statement? Because they say opposite things, both using percentages calculated from the table, but reaching opposite conclusions. Well, hopefully you realize that that B is the correct one. This is the one that makes the correct comparison. And here's why. It's important when you are making comparisons that you compare conditional distributions of the explanatory variable, not the response variable. Compare conditional distributions of the explanatory variable. Oops. Let's see if I can get this written correctly. So, of course, it's important to recognize which one would be the explanatory variable. So, you have to kind of use your common sense on this. Sometimes it's hard to tell, but most of the time it's pretty common sense. Does the preferred type of snack depend on gender, or does your gender depend on your preferred type of snack? Well, clearly it's your preferred type of snack. We're trying to figure out if the preferred type of snack depends on the gender. So it would make sense here that gender would be the explanatory variable. Number two is you always want to compare, using totals from two different rows or columns. So in our first example, we only looked at one column, the sweet column, and used 390 as our total for both fractions. So we're basically saying out of all the people who preferred sweet snacks, 300 were male and 90 were female, which really doesn't tell us anything because it doesn't tell us anything about how many males and females there were to start with. Since there are 4 times more males than females, we would expect there to be a lot more males in the sweet group than the females, so that doesn't really, so this is incomplete information when we're not comparing two different rows or column totals. If we were to think about this gender, now gender being the explanatory variable, then we would want to compare the conditional distribution of salty and sweet for each gender. And that's what we do here. So we can say sweet 300 over 400 for both of those. So this is comparing sweet and sweet. Could we also compare salty and salty? We sure could. We could also say 100 out of 400 males, or 0.25, preferred salty, and 10 out of 100, or 10% of the females preferred salty. So we can see that both male and females preferred sweet, but the females preferred sweet at a little higher percentage than the males did. We could also make a segmented bar graph really easily for this. So remember, the bars are the same length, and it's just the segments that are different. So here's the bars, and I'm going to say, I'll make a little legend that we'll call this sweet, and then we'll just make it, this will be salty. And for the males, we have 75% sweet. So if I were to divide this kind of into, make a scale here, and this would be 100%, and this would be 50%, 75%, and 25%, we could divide this and say here are the males that preferred sweet, and then the 25% preferred salty. For the females, 90% preferred sweet. So we'd have a bigger bar for the females, a bigger section for the females who preferred sweet. So that bar, or using these two whole rows, so we're comparing the female row, the female conditional distribution to the male conditional distribution. That answers our question correctly. One more comment about how A is misinterpreted. The first part of the sentence is actually correct. It says, since 77% of those who prefer sweet snacks are male and only 23% are female, that part's correct. It appears that males prefer sweet snacks more than females do. The incorrect part of that is it's not that males prefer sweet snacks more than females do. It's the fact that there are 4 times more males than females in our sample, so of course there's a whole lot more people in the group that prefer sweet snacks that are male than are female. So be really careful when you interpret statistics that you are making correct comparisons with the conditional distributions of the explanatory variable.